Hey, today I'll be talking about 5 basic concepts of programming. Now, keep in mind that this is not some standardized list of concepts. It's just, in my opinion, 5 things I think you should know about and be familiar with if you want to be a programmer. There probably will be a point in the future where I look back at this video and think, well, no, that's not right. There's a lot more to it. But anyway, with that disclaimer, here's the first thing on the list. Algorithms. An algorithm is a visualization of how you're going to solve a problem. Most of the time, algorithms are presented as these flowcharts consisted of different types of blocks. The most common blocks are the terminal block, which indicates the beginning or the ending of a program, the process block, which represents a set of operations, the decision block, which shows a condition that determines which path the program will take, and the input or output block, which is self-explanatory. So with all that in mind, you can use these blocks to present an idea on how you want to solve a problem. Let's give an example. Say you have a number, let's call it A. If A is positive, you want to divide it by 2, and if it's negative, you want to multiply it by 2. How do you go about making an algorithm to solve this problem? Well, it's simple. First, you want to input the number A. Then you have a condition where you ask if A is positive, or in other words, greater or equal to 0. If that's the case, you divide the number A by 2. If that's not the case, A is negative and you want to multiply it by 2. Finally, you want to output the result or the new value of the number A. By presenting this problem with an algorithm, we've broken down the problem into 4 simple steps. By completing these steps, you solve the problem for any given number. In conclusion, we can say that an algorithm is a set of rules to be followed when solving a problem. Anyway, these flowcharts and blocks are just a standardized way of showing your thinking process while solving a problem. If you have to present your idea to other people, you'll probably be using the previously shown flowcharts. However, if you're solving a problem for yourself, you don't have to do that at all. In fact, sometimes it can be really helpful to present your solution in some other way. You can basically do whatever you want, as long as it makes sense to you. You can open up Paint and draw a picture of what you're planning to do. You can write it down and explain how you're going to implement it, or you can use pseudocode. Pseudocode is the middle ground between algorithms and just writing your idea down. It's an informal description of an algorithm, and because of that, it can be translated to any given programming language, which is not the case with some algorithms. The concept number 2 is syntax and coding environments. Syntax is essentially the grammar of a programming language. Although it differs from one language to another, there's a lot of similarities and patterns. For example, something simple like printing out "Hello World" looks different in all these languages, but you can see that it's almost the same in Python and Perl. Once you learn and fully understand the language, it's going to be fairly easy to switch to a different one and learn the new syntax, since there's a lot of similarities. And after all, syntax is just a set of rules for a certain language. The principles are all the same. Syntax is something you're gonna have to learn if you want to be a programmer. When you're learning a new language, a lot of the times you're gonna have to look things up. And that's totally fine. I'm not a programmer myself, but I can tell you for sure that many experienced programmers look things up all the time. Another thing that can help you a lot when learning a new language is the autocomplete in almost any code editor. And speaking of code editors, something that I've always wondered about programming when I was younger is, how do you actually write a program? Where exactly do you type the instructions and the lines? Well, there's a program that takes your code and builds it into a new program. This is called an IDE, which stands for Integrated Development Environment. An IDE normally consists of a source code editor, builder, and a debugger, and it provides basically everything you need for software development. As you can see, the most popular ones are Visual Studio, Eclipse, Android Studio, and Vim. according to this study from 2 years ago. Another thing about syntax and writing code in general is how you write it. It's okay to have different styles of writing code. Some people like to open their brackets in the same line, others like to open it in the new line. But there are some universal things you should get used to when writing code if you want your code to be clean and easy to read. And you want that for a number of reasons. Let's say you go back to an old project and want to read your code. If it's not easy to read, you won't have an idea what's going on even though you wrote the code yourself. Or let's say you're working on a project with someone else and they need to use your portion of the code. If they have to go through and analyze everything you wrote to find what they need, that will take forever. That's why you should follow these rules and make sure your code is easy to read. So generally, you want to name your variables something that makes sense and is logical. And if you don't, next to the declaration, you can leave a comment saying what that variable represents. Writing comments is good in general, as long as you don't overdo it. Another thing is leaving space between certain parts of your code. If you don't do this and your code is all glued together, it's 10 times harder to read it and have a visual representation of what is what. In the end, if you follow all these rules and you have a nice IDE that will color keywords and stuff like that, you're gonna have yourself some pretty sexy looking code, if you ask me. Concept number 3, functions. So we all know how functions work. You have a function name and the function parameters. If you want to call a function, you type its name and the parameters in parentheses. For example, Fibonacci of 7. As a result, the function will return a value of 13. In this case, the return type is integer, the function name is Fibonacci, and the only parameter is 7. The only thing we don't see is the function's body. Well, most of the time, you don't care about the function's body, you just care about the results. What I'm trying to say is this. Functions help you look at the big picture and solve the main problem. Once you write a function and it works for any given parameter, you don't have to worry about that chunk of code ever again. You just call the function and give it the parameter you want. This makes for much shorter code that's easier to read, which, as I said, helps you focus on the big picture. It also avoids duplicating code. Let's say, for example, that you have to solve this problem. You have numbers A, B, and C, and you have to multiply elements A and B of Fibonacci sequence and divide them by the element C of the Fibonacci sequence. Here's how I solved this problem in C++ with and without using functions. This is with using functions. First off, I input the numbers A, B, and C. Then I say D equals the Fibonacci of A multiplied by Fibonacci of B divided by Fibonacci of C. Of course, Fibonacci is a function that I defined up here. And as I know that the function works, I don't really care about its body, which makes for really clear code in the main function. I also use the function showResults at the end to print the values of the variables A, B, C, and D on the screen. And this is without using functions. As you can see, the code is a lot longer and there is no clear indication of what's going on, as opposed to before where you could easily see that I'm multiplying two Fibonacci numbers and dividing them by the third Fibonacci number. So to sum up, functions are a vital part of programming, and here are the main reasons why. They encapsulate tasks, which I talked about earlier, where you only care about the result of the function and not its body. They let you reuse code, which makes your code shorter and easier to read. They enable easier shareability and allow you to break a program into more manageable pieces. Typically, when we discuss functions, we're talking about user-created functions. But other, perhaps more important and more frequently used ones are built-in functions. All programming languages have functions that you can use without having to write them yourself. Functions like scanf, printf, strcpu, sqrt, log, and so on. They're all contained in certain libraries of functions and variables, such as stdio.h, string.h, math.h, and so on. Not having these basic functions built in would be absurd. Also, today, a very small percentage of things are written from scratch. There's a function for almost anything. Number 4, objects. An object is a particular instance of a class where the object can be a combination of variables, functions, and data structures. For example, let's say we have a class of tables, and a table has certain properties such as height, length, number of legs, material, and so on. Then we have an object of that class, for example table 1, that has a height of 1 meter, length of 70 centimeters, 3 legs, and it's made out of wood. Next, we have another object of the same class, table 2, with a height of 1.5 meters, length of 2 meters, 4 legs, and it's made out of metal and glass. Finally, we have table 3 with the height of 74 centimeters, length of 80 centimeters, 1 leg, and aluminium as the material. You can see that all these objects are instances of the class table, and they all have properties of that class, but the values of those properties are different for each object. Another thing is that all of these tables have different functions. For example, you can use table 2 to serve dinner, or table 3 to put in the garden and set your flowers on it. So if I had defined a class of tables, I can write something like this and make a new object, in this case T1. But this is in case of a user-defined class. Just like with functions before, there's a lot of built-in classes in all programming languages. For example, integers, characters, strings, and so on. Number of files and table name are variables, or objects of the classes integer and string. From the example of tables, you can notice that these objects resemble objects in real life. And if you think about it, everything you see around you is an object of a class. This is the idea behind object-oriented programming languages, using logic and the creation of objects that can handle data and behavior. Many popular high-level programming languages support the paradigm of objects, such as C++, C#, Java, JavaScript, Python, Visual Basic, PHP, and so on. Others, such as C, Pascal, Fortran, Basic, are not object-oriented. So, how do these languages differ from each other? Well, object-oriented languages revolve around these 4 fundamental concepts: inheritance, polymorphism, abstraction, and encapsulation. I won't go too much in depth about all of these, but I will say something about each of them because I think it's important to understand the idea behind them. Inheritance enables a new class to take the properties of an existing class. For example, let's say you have a class called animal. A class called carnivore can inherit all properties from the class animal, and on top of that, it can have some properties on its own. The existence of these base classes and derived classes obviously makes managing relationships between classes a lot easier. Polymorphism enables you to redefine a function in a derived class. For example, your animal class has a function called makeSound, and your derived class called dog and cat should obviously make different sounds. So this is where being able to redefine the same function differently for each derived class comes in. Abstraction is the concept of using functions without worrying about how they work, which is something I talked about earlier. Hiding unnecessary parts of your code and separating it into functions in order to focus on the main problem. Finally, encapsulation is the concept of having private and public properties and functions of an object. This enables you to limit access to certain parts of an object, as opposed to public properties. Private properties are only accessible to the class itself and not to anything outside of it. This is in a sense similar to abstraction because it also helps you look at the big picture. Another thing I wanted to mention when it comes to objects in programming are pointers and references. Most programming languages support them, and they're both used to have one variable provide access to another one. A pointer is a variable that holds the memory address of another variable. Here's an example of declaring a pointer to an integer in C++. As you can see, the pointer is declared with an asterisk symbol, and a reference variable is another name for an already existing variable. You can recognize it by the ampersand symbol. Here's an example for it as well. I'm giving examples in C++ because that's the language I'm currently learning and am familiar with. The fifth and final concept, debugging. This could have been a part of another concept I already talked about, for example, the coding environments and IDEs, but I wanted to separate it because I believe that it's important no matter what language you're using and no matter how long you've been programming. Good debugging and understanding of the problem equals good programming. Anyway, let's start off by saying what debugging is. Debugging is the process of finding and resolving defects or problems within a program that prevent it from working correctly. In my opinion, it's really important to understand how to properly debug because no matter how experienced you are, you're going to have bugs and you're going to learn how to fix them. What I've seen many people struggle with when it comes to programming is getting stuck on a bug, trying to find what's causing it by aimlessly changing parts of their code and eventually giving up on it. What you need to remind yourself in this situation is that your program is just executing the code you wrote line by line. And if you carefully follow the execution of each line and how it affects your variables, you can 100% see where the problem is and fix it. Sometimes writing things down on a piece of paper really helps. Each time the state of your variables changes, you write it down. That way, you'll be able to track everything and see the core of the problem. Besides the things I already mentioned, here are some useful debugging techniques. First of all, use your debugger and everything it offers. Debugger is a software tool which enables the programmer to monitor the execution of a program, to stop it, restart it, set breakpoints, and change values in memory. All of these things can be very useful and are there for a reason, and you should learn how to use them even if it looks boring at the moment. Print debugging is basically tracing how far the program works correctly and at what point things start to fail by printing the current state of the program after each line. Post-mortem debugging is debugging after the program has already crashed. Maybe there's an error message that pops up and can tell you more about the bug. Maybe there's an error code, or maybe there's a memory dump file that you need to analyze in order to figure out what went wrong. The wolf fence algorithm is named after a story that goes like this. There's one wolf in Alaska. How do you find it? First, build a fence down the middle of the state, wait for the wolf to howl, determine which side of the fence it is on, repeat the process on that side only until you get to the point where you can see the wolf. So if you apply this to debugging, you determine which half of your code works and which doesn't. And then you repeat the process on the side that doesn't work and so on until you find the bug. Pretty self-explanatory, and in case you can't exactly test your program in half, then split it into as many parts as you need to. This is a good practice in general, not just when it comes to debugging. Something else you should pay attention to when debugging is nonlinear code execution. This is where the whole process of tracking down the bug gets a bit more complicated. If your program has structures like while and for loops, you should check if the structure executes exactly the amount of times you expect it to. And if, God forbid, you have instructions like go to, you should be careful not to get stuck in an infinite loop. One of the reasons for the declining of the use of go to statements was that they were harder to understand. Structured programming proposes that these statements are not necessary to write a program because some combination of the three programming structures of sequence, selection, and iteration are sufficient for any computation in a program. Anyway, that's it for this video. Those are the 5 concepts I think you should be familiar with if you plan on being a programmer. I'd like to point out that I'm not a programmer myself, but I hope to become one, and this is just me sharing what I learned in the process. Since I spent a lot of time making this video, I would really appreciate it if you would leave your thoughts in the comments. Let me know if you learned something new, because that's the whole point. And finally, don't forget to like and subscribe for more videos like this. Thanks for watching, and I'll see you next time. Peace.